go through problem solving with vertex form. Okay? This is obviously our vertex form of our quadratic, and this models the height of a rock being thrown. T representing time, so how far in time it is, and height being how high the rock is. We have our vertex form, so the rock does some relationship like this. It's going to be really 2 or 3 major things they can ask us. One of the things they might ask us is, what is the max height? Okay. Another thing might be how long it was in the air. And maybe another one is, when is it 10 meters in the air? Okay, so 3 major things we're going to solve with vertex form. So, first of all, max height. Does vertex form help us find max height easily? Yeah, what is the max height of this rock?
22.
22, right? The vertex is the maximum or minimum. Because it's facing down, okay, because that's negative, we know it has a max value. And at what time is it at its max height? At 2 seconds, right? This being our x value, and this being our y value. So, at 2 seconds, the rock is 22 meters into the air. What if we were in standard form? What we would have had to have done to solve this?
Wait, what?
We could have factored, but it's longer. What's something we learned this chapter?
Quadratic equation or
How do we change to vertex form? To go from standard to vertex, we complete the square. So the fastest way to solve this, had it been in standard form, would have been to complete the square, and we would have had vertex form. Okay? How long was it in the air? Well, because it's referring to height, okay, we're looking when height is 0. Okay? Because that's where the beginning and end of this will be. So at some point, it'll have been shot into the air, and then it will hit the ground again. What are the 2 points when it hits the ground called?
0.
Yeah, our zeros are our x-intercepts. So we need to find our zeros. So we're going to set height equal to 0. Is equal to negative 5 t minus 2 squared plus 22. Now, how can we find x-intercepts from standard form? Factor it, or what else did we learn in this chapter to do it? Quadratic equation, right? But because we're in vertex form, there's a different way we're going to go about doing this. We're going to isolate for t. Okay? And you're going to notice we'll get 2 answers again. To bring positive 22 over, what does it become? So we get negative 22 is equal to negative 5t minus 2 squared. Next thing we want to do is move over our negative 5. When we move our negative 5, what operation is it? Division. Okay? Because it's technically multiplication on that side. So we're going to get negative 22 over negative 5 is equal to t minus 2 squared. Okay, so let's equate what we have here. And because it's a negative divided by a negative, it's the same as a positive divided by the positive values, 4.4. So we have 4.4 equals t minus 2 squared. The next thing I got to move over is our power of 2. What does it become on the other side? Square root. Okay? What is the square root of 4.4? 2.09. We'll say approximately 2.1. Okay? So we get 2.1 is equal to t minus 2. Is that the only answer? Positive 2.1? What else is an answer? Negative. So our answer is actually plus or minus 2.1. So from this point, we split the equation. We have positive 2.1 equals t minus 2, and we have negative 2.1 equals t minus 2. So we're going to end up with 2 answers. Okay? I bring 2 over, this becomes 2.1 plus 2 equals t, which is 4.2. And in the other one, it becomes negative 2.1 plus 2 equals t, Now, when you bring a negative over, it becomes positive. You get negative 0.1. So, I want to think about this. The question was asking me how long was it in the air. This time is a negative value. Does this make sense? Do we have negative values for time? No. So the rock would have started at 0 in this case. And when would it have hit the ground? At 4.2.
Yeah.
So, sorry, we fixed our mistake here. This should be 4.1. So, the rock was in the air for 4.1 seconds. Now, we'll go into our third one. I briefly talked about it. When is it 10 meters in the air? Well, we're going to replace h at t with 10, okay, which will look like this over here. So 10 is equal to our equation. And we go through the same process as on the left to isolate for t, starting with bringing 22 over, and we'll get two values. At 2 points, it will have been 10 meters in the air. It'll pass it on the way up when we throw the rock, and then back on the way down. Okay, so at 2 times, this rock will have been 10 meters in the air.